Hello everyone, this is the second episode of my Arduino Basics series. Today we are going to bring some basic logic or branching into our code with the push button and with the digital read function. Let's get started. This project will work like this. We press the push button and by that an Arduino pin will read high, aka 5 volts. When the pin reads 5 volts, another pin will make a green LED light up. However, if the button is not pressed, the pin reads 0 volts and the red LED lights up. For this project we will need a breadboard, an Arduino, push button, a 10 kilo ohm and two 220 ohms resistor, 2 LED, 8 male-to-male jumper wires, and the USB cable. The only new component is the push button, so let's have a closer look. The only way to connect it to the standard breadboard is like this. Now it makes sense to talk about sides of a push button. It has 4 terminals, 2 on the left and 2 on the right side. The upper right terminal is connected to the lower right terminal and the upper left is connected to the lower left. Rails with the same color means they are connected. When the button is not pressed, there is no connection between the left and the right side. However, if the button is pressed, a connection is established between the two sides, so all 4 terminals will have the same voltage. Let's connect the circuit. This time we will make use of the long rails of the breadboard. Connect the Arduino's 5 volt supply to the red rail and the ground to the blue. Now we connect the red rail to the right side of the push button and the left side to a digital pin of your choice. I will use pin 3. Unlike in the previous tutorial where we used the digital pin to apply, now we need it to read 5 or 0 volts. Now, if we leave this part of our circuit like this and write the code, we will encounter a problem. Namely, the Arduino will read seemingly random voltages and the LED will not exactly behave as it should. The problem is, the pin of the Arduino will read all kinds of noise from the environment. The most dominant is the sine wave from your electric appliances. So the reading will oscillate between low and high and it looks like both LED is turned on. When this happens to a pin, we say it is a floating pin. This is not the kind of behavior we want. We want it to read 5 volt when the button is pressed and 0 volt when it is not. To achieve this, we need a resistor again. Connect a terminal of a 10 kilo ohm resistor to the pin which we will read and the other terminal to the ground. This way, when the button is pressed, the Arduino will read 5 volt and 0 volt otherwise. The reason behind why this works is the following. When the button is not pressed, no current is flowing in or out of the reading pin. This also means that no current is flowing through the resistor either. Since no current is flowing through the resistor, Ohm's law says the voltage drop is also 0. Because of that, and because the resistor connects the reading pin to ground, the reading pin has the same potential as the ground, 0 volts by definition. Now it won't read all kinds of noise, but keeps reading 0 volts until we press the button. When the button is pressed, the reading pin is directly connected to 5 volts, so it will read that. When we pull down a pin's voltage to ground with a resistor, we call that a pull-down resistor. We can also use the pull-up resistor concept. The idea is exactly the same with the pull-down, the only difference is it does not pull the floating pin to ground, instead it pulls up to a given voltage. Now we need to connect the two LEDs the exact same way as we did in the first video. Let's move on to the code. Let's start by declaring the variables. We need 2 pins to control the 2 LED and another pin to read the button state. I will name the 2 LED pins red pin and green pin, and the one which reads the button state button pin. Next, we have to declare the pin's functionality with the pin mode function in the void setup. The LED pins will be outputs and the button pin is an input. Now the void loop. We want our program to do something if a certain event happens and do something else if it doesn't. We can do this by using conditionals. The syntax is the following. We type if and then parentheses, and in the parentheses we have to write an expression which evaluates to either true or false. So we write in the parentheses next to the if statement the following: digital read and button pin. This function takes one input, which pin we want to read, and it returns a digital value, high or low, depending on what voltage is currently applied to the given pin. After the if statement's parentheses, we have to write curly brackets, like we've seen in the void setup and void loop. The code we write between these brackets will be executed only when the condition next to the if statement evaluates to true. In our case, we want to set the red pin to low and the green to high. We can do this with the good old digital write function. Now you might ask, what happens if the expression next to the if statement evaluates to false? Well, if we write nothing more, when we press the button, we enter the if statement and turning on the green LED and off the red. When we release the button, the green stays on and the red off. No matter how many times we press the button, we can get out of this state. However, we can write an else statement which tells the program what to do when the if statement evaluates to false. Because of that, the else does not need a parenthesis. Just type else and then curly brackets and the code goes inside them. We want the Arduino to turn off the green LED and turn on the red. Again, we do this with the digital write function. Now we can upload the code. We just controlled the flow of the program. The program executes a block of code if something happens and another if it doesn't. With that, we implemented some basic logic into our code. We can also do another if-else structure inside the if and else also, and keep doing that as many times as we want. This opens up a lot of possibilities which we will use extensively in the following videos. In the next episode we will use a variable resistor, aka potentiometer, read analog values using the serial monitor, and measure what voltage is the border between high and low for the digital read function. If you got interested in doing these projects and want to follow along, I give you links to the kits I use in the description below, so you can have the exact same components I have. If you have any question, observation or feedback, please leave a comment below. Also, if you liked this video, let me know by like, share and subscribe. Thank you and see you in the next episode.